I'm sure you've actually seen the composite pattern before, but you might have called it something else. You might be familiar with a tree view, or you might be familiar with nodes in XML documents. Those are all composite patterns. So the general problem that a composite pattern solves is that you have an object that is composed of similar child objects, and each of those children may have their own children, and so on, so you get a family tree. So you commonly see it in a tree view, as I said, and that's the visual representation. But you also see it in XML or HTML DOM docs as well, where you have nodes. The one subtle little difference there is that with a composite pattern, all of the objects within the tree are of a similar type. So a node and an element might be a little bit different in an XML doc and may not descend from the same type. A composite pattern tries to allow them to descend from the same type so they can all be treated the same way. Another example would, of course, be a file system folder. Or you can have supervisor employees, the notorious org chart. And yes, I did find an image of the Northwind database org chart. If you're doing a social networking app, users and followers. A user may have a bunch of followers who have a bunch of followers, and onward, onward, onward. It's the whole basis of LinkedIn and Facebook, of course. All of those relationships. And then if you're interested in actual hardware, manufacturing assemblies. So if you have a piece of hardware, perhaps a car, it consists of more assemblies. And those assemblies consist of assemblies. And then you finally get down to the individual nuts and bolts, the individual parts. So the formal definition is that the composite pattern composes objects into tree structures to represent part-whole hierarchies. And the composite lets clients treat individual objects and compositions of objects uniformly. And that's the part where all of the objects descend from the same class. I can treat a parent node the same as I would treat an individual element. So each one of those objects descends from an abstract class, or implements an interface. And that abstract class or interface is common to each one of the objects in the composite. And then, of course, the parent objects will have a collection of children objects. So for our example, instead of the classic org chart, I thought we might do a manufacturing parts list. So each of our end products contains a number of assemblies. For instance, that circuit board down there. If we're going to be building computers, we have a chassis, we have circuit boards, we have RAM, we have hard drives, DVDs if we're not Apple. So there are a number of different assemblies and individual parts that go into the making of a computer. And each one of those assemblies, of course, may contain parts. A power supply contains a transformer and cable, and each assembly may also contain other assemblies. So for example, the display can also contain a screen assembly. So for our example, we're going to have a base assembly abstract class. And it could be an interface, but for this example, we'll use an abstract class. And because all we're doing is creating the parts list, we're only going to have two members on that abstract class. The quantity, the number of parts we need, and the name, just the name of the assembly. Obviously, if we're going to do this in a real manufacturing facility, we'd probably want part numbers and manufacturer numbers and manufacturers and quality levels and all sorts of good stuff. But in order to just demonstrate the composite pattern, we'll simplify that part and just use quantity and name. Then we'll also have a write parts list method. And our client is going to ask all of the objects in the composite to write the parts list. And they'll essentially write themselves and any children they have. And then there will be add and remove methods in parent assemblies. So the parent assemblies will be able to add and remove child assemblies. So we'll have two different classes that will implement our abstract interface. The first will be an assembly implementation class, and that's effectively a parent. So it can have an internal collection of child assemblies. And the children are also base assembly types, which means that they can also be either a parent or a simple child object. The write parts list method, in addition to writing the information for this particular assembly, will also call the same method on all of the children of the assembly to get them to write their information to the parts list. The other concrete implementation we'll have is a part class, and the part will be a basic part like a nut or a bolt. It won't have any children objects, so it also will not implement add and remove. In the example, we're going to throw an exception. Now this is where it becomes a little bit interesting. And it gets to your choices of an abstract class or an interface. An interface would require this to be implemented. It could still throw the exception, but it would require that this method be implemented, and the implication is that the method would actually do something if it was on an interface. An interface could be considered to be a contract. So the client might expect, even on a part implementation, because it doesn't know the difference at its level, that the add or remove might actually do something. So the interface probably shouldn't have add and remove on it. We have a similar issue with the abstract class. It still has add and remove on its public interface that the client can call. And the implementation of an individual part doesn't have anything to add or remove. Because the client doesn't know that the add and remove are not implemented, throwing an exception might not be a good thing. Because of course the client doesn't know that it can't use those methods, so you may end up blowing up the application by mistake. The other side of that, however, is that if you allow them to call add and remove on an assembly that has no children, well, they're trying to add or remove something, so there's a logic error there. So throwing the exception might be a good thing. The compromise might be to use asserts so that you can see it in development and debug, but in release it's not going to throw. So a lot of interesting choices on what would seemingly be a relatively simple object. So here's our class diagram, and we have our base assembly abstract class, which has fields for name and quantity, and we have methods for add and remove, as we just discussed, and write parts list. And then our two descending classes are the assembly class that does indeed actually implement and do something with add and remove, and can have child objects, and the part class, which is simply just a single part. So that's what the composite looks like. And as you can see, if we have multiple assemblies with multiple children, we start walking that tree.